Hi, good morning, ladies and gentlemen. My name is Kusmono. I'm from Department of Mechanical and Industrial Engineering, Faculty of Engineering, Universitas Gadjah Mada. Today, I would like to present my work. The title is Fabrication and Characterization of PLA nanocrystalline cellulose nanocomposite filaments for 3D printing. And go to the next slide. This is the outline. I would like to start from introduction and then objectives, experimental procedure, characterization, result and discussion, and the last one is conclusion. This is introduction. So everybody now is talking about 3D printing, and we can call 3D printing by additive manufacturing. So what is the 3D printing? 3D printing is a process of fabrication of 3D objects through layer by layer from computer-aided design or CAD model. There are so many advantages of 3D printing, is like including rapid prototyping, wide choice of material, objects, can produce object with the complex shapes, low cost, and we can produce a product without special tools, low or zero waste manufacturing. There are so many potential applications of 3D printing. First, we can produce prototyping, bioprinting, food, and also component of automotive. It means manufacturing. So I think we have known that there are types of 3D printing technologies. First is powder solidification. The second one is liquid solidification, and the third one is extrusion-based system. So in this work, I use fused deposition modeling or FDM, and also we can call fused filament fabrication. Yeah. There are so many advantages of the FDM. First, it's easy to produce, it's easy to use, and low cost, reliability, simple, affordability, minimal wastage, and material availability. But FDM also has disadvantages like low strength, easy distortion leading to the limited application of FDM in cost-effective, functional load-bearing application as well as in large-scale production. In this study, I use PLA filament. Why I choose PLA? Because PLA is a biodegradable polymer, good mechanical properties, and optical transparency. But PLA also has disadvantages such as low thermal stability, crystallization ability, and draw ability. So I would like to improve the properties of PLA by introduction the reinforcement nanomaterial. In this case, I use nanocrystalline cellulose (NCC), and this NCC was prepared by isolation by sulphuric acid hydrolysis using ramie fiber. Why choose the nanocrystalline cellulose? Because NCC has a nano-size cellulose 1 until 100 nanometer in diameter, 10 until 100 nanometer in length. Also, NCC has high strength and stiffness, high surface area, low thermal coefficient, and so on. So in this study, I would like to develop the new filament materials from PLA NCC nanocomposite. So this is the objective of my study. First, I would like to study what is the effect of NCC content on the diameter of PLA nanocomposite filament. The second one is I would like to investigate what is the effect NCC content on the tensile properties of PLA nanocomposite filament. And the last one, I would like to study what is the effect of NCC content on the thermal stability of PLA nanocomposite filament. So this is experimental procedure. We started from the drying PLA pellets and NCC powder at 60 degrees Celsius for 6 hours. This drying to release the water absorbed in this PLA and also in NCC powder. And then we mix particular mixing of PLA pellets and NCC powder. After that, we produce filament by using extruder machine with a different NCC content, start from 0, 1, 3, 5% of NCC at the constant temperature of 185 degrees Celsius. And after that, we can produce nanocomposite filament. So this figure is the filament. After that, we do diameter measurement and also FTIR analysis, tensile test, and also TD analysis. So this is a result and discussion. The first is FTIR spectrum. So there are three samples. First is PLA matrix, and the second one is PLA NCC 1 weight percent, and the C is PLA and NCC 5 weight percent. So from FTR spectrum, we can see that there is a new peak at 1365. Yeah. And this peak is corresponded to the sulfonate group. And another data is diameter of filament. Yeah, we can see here that the effect of the adding NCC on the diameter. So from this figure, we can see that the diameter of filament was lower than 1.75 millimeter. Why lower? I think because there is a screen gauge phenomena during the cooling process from the melting of pellet. So this is a tensile test. So we can see here that the highest value in strength and stiffness was achieved at 1 weight percent NCC content. What happened with the 1 weight percent NCC content? I think at 1 weight percent NCC, there is a homogeneous dispersion, and also there is a stronger interaction between NCC and PLA matrix. So the highest values in strength and stiffness can be achieved at 1 weight percent NCC. But if we adding more than 1 weight percent, the strength and stiffness decrease. Why decrease? I think this was related to the agglomeration of NCC as active weaker point. So this is the result of tensile test elongation at peak also. So the highest elongation at peak was option at the 3 weight percent NCC. After that, the elongation decrease. And another one is TGA result. So from the result, I think we can see that the adding NCC decrease slightly the thermal stability. So what the reason? The reason is maybe attributed to the presence of sulphuric groups on the NCC surface during sulphuric acid hydrolysis. And then and this one is TGA result also. So this is a curve of TG and DTA. From this, we can see that the thermal stability of PLA was not significantly affected by the present NCC. And the last one is conclusion. From the study, I can be draw one conclusion. First is tensile strength and elastic modulus increased by 90%, and also the elastic modulus increased by 13.5%. But if we adding more 1% of NCC, the tensile strength and elastic modulus decrease. And the second one of conclusion is adding NCC had no significant effect on the thermal stability of PLA and NCC nanocomposite filament. And the last one of the conclusion, the optimal NCC content was achieved at the 1% of NCC content, which produce the highest values in the tensile strength, elastic, and modulus. I think that's all from my presentation. Thank you very much for your attention.